Right, I'm just going to go through this review 6 for Year 10, Term 2. Just going through how to use your calculator to help answer some of these questions. I think calculator skills is one area where we can all improve. So I'm just going to run through and show you how to use your calculator as we go, and hopefully that will help you out a little bit. First one we have here, the height of a projectile is given by h equals 60t minus 5t squared, where h is the height in meters and t is the time in seconds. When will the projectile hit the ground? So I've gone ahead and I've done it. Obviously it hits the ground when the height above the ground is 0. So there are 2 times. Obviously it was launched first, so the time we're looking for is t equals 12. The projectile will hit the ground after 12 seconds, but you could of course do this on your calculator. And so we're just going to go through and try and do all of these using our calculator as well. A couple of ways you could do that one. You could definitely go to graph mode and have a look at the sketch. So if I go into here, we don't need those ones that are in there, so I'll delete. Yes, I'll delete that one and delete the one underneath as well. Let's have a look and see how we go. So we've got 60t minus 5t squared. So 60, when we're putting a variable in, it's this button over here, the x, theta and t button. It's going to come up as x, but that's fine. We just need to know that it's a t when we're actually doing our working. 50t squared. Now, if we just have a look at, we can get it to draw it straight away. Doesn't look particularly helpful there, does it? Our standard viewing window runs from -10 to 10 on both the x and y axis. That doesn't make a lot of sense what we've got here. So we need to use our viewing window. You'll see I hit shift and then V window and just choose some sensible values for x. So obviously x can't be less than 0. If I throw something in the air, I doubt it's going to last longer than 20 seconds. We already know the answer is 12, but 20 would be plenty. We're looking at how high in the air is this going. Well, I'm interested in the height being 0, so I guess I can put 0 in there. Maximum height, I don't know, maybe 20 metres is a long way up. Could I throw something higher than that? Maybe. Probably. But we'll have a look and see if that's any better now. Oh, well I didn't get the maximum height, but I certainly got where it's going to hit the ground again. That's enough for me to actually go ahead and solve. G-solve, you can see it in yellow, you can hit shift and G-solve. But when you're in the graph itself, it will automatically just come up. And intersect is what we want. So when did it graph? Oh no, not intersect, I told a lie. That's if we have 2 lines, dummy. You know, I can't be trusted with one of these calculators. You guys need to know how to use it a lot better than me. G-solve, and so the roots of the equation, that's the other name for the x-intercept. It's going to tell me 0, 0 first. X is 0, y is 0. That's no good. We push across, move to the right, and now it's saying x is 12, y is 0. So you could draw a quick sketch and do that. If you wanted to get a nicer sketch, you could always make sure your window covered a little bit more so you could see the axes in there. It might make it a bit easier for you to draw. This time I've gone -15 to 15. I could even have my scale going by 5, so it'll put a little dash on there every 5. Height, it won't make it go down to -5, but it'll just let me see the axis again. And obviously I didn't go high enough. Maybe I threw it as high as 80 metres. I don't know. It was projected into the air. Could have gone up a fair way. Whoa, it went way higher than 80. You can see it's still going up. But you get the idea. Quick way you can do it is just to zoom out, and it will zoom out from the area you're doing it. That's another way you can muck around with it, but it's usually best if you work on coming up with the window yourself. There we have it again, and as before, G-solve the roots. The first one's going to be 0, 0, and the second one was 0, 12. Oh, sorry, 12, 0. Alright, so, well, that one closed the wrong thing. There we go, we've got it back anyway. Leaking oil tanker is producing an oil slick which is increasing at 15% per hour. If the oil slick is approximately 250 square metres initially, how large will the oil slick be after 8 hours? Again, we can just use our calculator to come up with this stuff fairly easily. Graph mode is again one way we can do it. 200 or 250. Increasing by 15% means multiplying by 1.15 to the power of x. And so if I draw that, we're going to see it's going up. Oh, but now we need to change our window again, don't we? It started at 250 on my y values. I'm only really interested in positive x values again. So I'm going to go 0 for, well, it says 8 hours. I'll go to 10 hours just to give me some idea. And then my y values, well, it started at 250, but I still want to see 0. And I don't know, it's getting bigger, but hopefully it's not getting too big. I'll go to 1,000 and see if that's enough. You could, of course, calculate it. Well, that looks pretty good. because remember this was going up to, what did I say, 10 hours maybe. I want to calculate something again, so I'm going to graphically solve, so Shift and G solve. This time I'm looking to calculate a Y value. That's not one of these options there, so I press F6 to go across, and I want to calculate the Y value when X is 8. And it's just going to go along and tell me 764.76 square meters approximately. So again, easy enough way to go ahead and do that there. That's easy enough to type in on the calculator though. But some people like to do that. Just solving equations. If you are asked to solve an equation, and you should all be confident with your algebra for these, but let's say you know that sometimes you're prone to making an error, you can, on your calculator exam, just put this in to your calculator and it will tell you the answer. So I'm into run matrix here, so just run matrix, the regular where we solve equations, and I'm going to go options, calculate, which is F4, and then solve n, F5 there. And I'm going to do this bottom one here, so 2x minus, so 2x minus, and I've got 7 over x plus 1, push across. Now I need the equal sign. The equal sign's above the decimal point there, equals 3. Oh, why did I say? Ah, there. 2x minus 7 over x plus 1 equals 3. That is what it equals. There we go, and your calculator's going to figure it out for you straight away. -2 or 5 over 2. You'll see that's the same answers that we got doing all of our working. You can write the equation, write that you use solven, and put down the two answers if that was on a non-calculator, if that was on a calculator exam. That's the sort of thing I'll put on a non-calculator, but it may come up as part of a calculator question. Rectangle 7 centimeters longer than it is wide and has an area of 17. Find its dimensions. You can see here I've said you could use equation solver, graph node, solven on your graphics calculator. Let's have a look at how we do this on our equation solver this time. We haven't done that yet. So you can see here, here's equation. I'm going to go down to equation, click execute. This one is a polynomial equation, so F2, and it's a quadratic, so that's degree 2. And now I just put in the coefficients. The first coefficient is 1. The next coefficient, like the coefficient of W, is 7. And the coefficient of C is -17. See here, they want you always to have it equal to 0, so you may need to do a slight rearranging there. But if you do that correctly and you click on solve, it's going to tell you, well, it tells you up here 1.9083 and the other one -3.90. Of course, if possible, we want you to give the exact answers, so -7 plus 3 root 13 on 2 and -7 minus 3 root 13 on 2 are our two answers. Now this is one where you need to make some interpretation. Here we got the two answers, -7 plus or minus root 117, which is simplified to 3 root 13 later, over 2. But because W had to be greater than 0, because this is the width of a rectangle, we didn't need the -7 minus 3 root 13, or the -7 minus root 117. So there'll still be some interpretation. You can't just write down what your calculator's given you and be done with it. You still have to think about it, but if you think clearly, it's pretty straightforward. Quadratic equation has a turning point of 3, 4 and passes through -136. Find the equation. So there you go, they've got you there. This is one where, again, you could substitute in the values. So I could do from this line here, I could put that in on solver and get the answer. That looked a bit unhelpful. But let's go back to menu 1, run matrix, and remember it was options, calculate, solve n, and this time I'm going to go for 36 equals. 36 equals now variable. I still have to use the x input, even though it's a here. Just make sure you write A on your paper. Well, -1 minus 3, I'm going to even pretend that we couldn't do that. -1 minus 3 bracket squared, and now +4, close my bracket, and solve n will find it for us. More solutions may exist, but it found the solution too. That is, of course, the solution we were after. Oh, a simultaneous equation example. This is the one here with records and cassettes, things you guys may have seen once in like an old 80s TV show or maybe something else like that. Let's have a look here and see how we go when we're trying to solve the simultaneous equations. You would have noticed before in equation, we go to equation here and we go to simultaneous F1, and I had two unknowns. So simultaneous equation unknown, 2r plus 3c equals 32, and you see they want you to have the coefficient variable equals the solution. So I've got it set up correctly, so it was 2 of my first variable, 3 of my other one equal 32, and the second one 4r plus 1c equals 29. We've input our information, we click on solve. 11 over 2, which is 5.5, and 7, which were the two values. And remember, the first one listed there, that was whatever you used as your X, and the second one you used as your Y. Records $5.50, cassette $7. Nicely done. So being able to use your calculator is going to make your life very easy here. Let's just exit back, we'll do one more of these. 1 plus 1 equals 4, a plus b equals 4, and then 1a minus 1b equals 1. Then you solve it and it tells you a equals 2.5, b equals 1.5. Not so bad. We've already looked at how to do those ones using Solver. You can of course just show your work and get them right. Oh, I didn't put the answer for b there, how unusual. Well, in that case, let's put the answer for b in ourselves while we're at it right now. Run matrix, we're going to go options, calculate, solve n, and here I go. 1 divided by k minus 1, so 1 over x minus 1. Go to the side, plus 3 over, and this time I've got k plus 1, x plus 1, equal sign above the decimal point in orange, equals 2. Close my bracket, and it's going to tell me the answers. So let's actually snip that in there now, so that'll be in there for you for next time. There's our answer for B. We can just do solve n of that, and it tells me 0 is one of the answers. 1 over 1 plus 3 over 1. Oh, 3 over... is 0. Oh, 1 over negative 1 would be negative 1. And 3 over 1 will be 3. Negative 1 plus 3 is 2. That's right. And if 2 is in, then I have 1 over 2 minus 1 is 1 over 1. And 3 over 3. 1 plus 1 is 2. Correct again. Another example here where you could use your graphical display calculator. I've just got two equations. I could just use Solver to solve that. This time, we've only got a little bit of time left on the recorder, but I'm going to go to menu, graph mode, just to show you. You could use Solver, but I could also just put in x plus 6 all squared. That's the left-hand side of my equation. The right-hand side of my equation, x plus 3 squared plus x squared. And if we have a look at those, oh, they've been drawn strangely. I'm going to go back to my regular viewing window, just my standard one, just to see if that looks any better. Oh, it looks pretty good, but they're not intersecting. I need to go up a lot higher. Change my viewing window, and let's go up to the maximum of 50. That should cover us. Oh, we can see one of the times they intersect now. They intersect once right there. If I go gsolve, where do they intersect? It's going to tell me when x is negative 3 and y is 9. If I push across, even though I can't see it there, it tells me the other answer when x is 9, y is 225. That should give you a bit of an idea about how to use your calculator on these. There are a couple more you can try there for yourself, but nothing new other than what we've done. When you're looking at question 4, they will tell you lots of answers. You'll need to think about which ones could be the sensible answers to fit inside a triangle. Hopefully that helps. Good luck with your revision. Catch you soon. Bye.